So, good day, Sir Roman. We are the Team 16, and we're about to discuss our Assessment 2.2, which is metrics and constraints. Firstly, here's our 5 constraints and metrics. For our first constraint, its performance and its metrics is processing speed. For our second constraint is security, and its metric is data privacy. For our third constraint is latency, and its metric is real-time operation. And for our fourth constraint, it's parameter, and its metric is stability index. And for our last constraint is time, and its metric is average handling. We're going to explain on how these 5 constraint and metric relate to our topic. For our first constraint is performance, and its metric is processing speed. Firstly, the meaning of performance. Performance in a system design refers to how well a system executes tasks or processes within a given time frame, meaning this shows how efficiently and quickly a system completes its work. And the meaning of the metric processing speed is the pace at which an individual takes information, makes sense of it, and begins to respond. Meaning, this describes how fast a system understands and reacts to the information. Processing speed directly affects performance by determining how quickly a system can process individual operation or transaction. This means faster processing speed means the system can handle more tasks in less time. Processing speed is measured by computing instruction per second task completion time called in gigahertz. This means this is a technical way to measure how many instructions a processor completes each second. Therefore, the higher the processing speed, the better the overall performance and responsiveness of the system.
Security data privacy. Security is the system's ability to protect data from unauthorized access or breaches. Data privacy focuses on properly storing, accessing, and protecting sensitive information. It ensures that data is only used for the right purposes and remains safe from misuse. Strong security helps maintain data privacy by keeping personal and business information confidential. In the cafe system, this ensures customer data is safe, builds user trust, and keeps the system reliable.
Our third constraint is latency, and its metric is real-time operation. Latency is the time interval between initiating a request and receiving a response. It is a critical performance metric, especially in real-time systems where delays can affect user experience and system functionality. This means that low delays are very important in a system that needs instant responses. Real-time operation is a special kind of operation system designed to handle tasks that needs to be completed quickly and on time. Because some systems are built to guarantee fast and timely task completion. And latency is measured in milliseconds or seconds. This represents the total end-to-end delay experience including network transmission, system processing, and queuing time. Meaning, the delay includes all the time taken by each step from sending a request to getting a response. Therefore, the lower the latency, it leads to a better real-time operation and the system responsiveness, while high latency reduces the user satisfaction and the effectiveness of the time-sensitive processes.
Parameter Stability Index. A parameter is a factor that defines how a system should work. The stability index measures how consistent and reliable a system performance is over time. A high stability index means the system runs smoothly without major errors or changes. In the cafe system, it helps check if the automation process is stable and working properly. This ensures consistent performance and dependable results.
For the fifth constraint is time, and its metric is average handling time. Time on a system is aggregate time a user, process, or application is actively involved in a computing system. Meaning, this is a time total spent using or processing in the system. Average handle time or AHT captures the total time it takes to complete a single transaction or customer interaction from start to finish. Meaning the AHT measures how long an entire task or order takes. Then by reducing the average handling time, the cafe can process more customer in less time, improves staff productivity, enhance customer satisfaction, and lower operational costs. Average handling time is measured in seconds. and its formula is AHT is equals to total time spent on orders divided by number of orders. Therefore, the lower the average handling time, the more efficient the system is.
Performance. Processing speed. Checked how fast the system handles orders to reduce waiting time and meet cafe demand. Security. Data privacy. Identified risk in storing customer and business data, ensuring it remains protected and private. Latency. Real-time operation. Observe the need for quick system response to maintain smooth cafe operations. Parameter. Stability index. Noted the importance of having a consistent and reliable system, especially for the automated process. Time. Average handling time. Analyzed how staff handle orders to make service faster and more efficient.
This is how we measured our 5 constraints to our topic. For performance, we measured the system's throughput, which refers to how many orders the system can process per second, or the speed of the processor measured in gigahertz. This gives us an indication on how effectively and efficiently the system handles workloads and completes tasks. For our second constraint, security, we quantified it by examining audit, compliance, and reviewing access logs. These methods help us ensure that only authorized personnel access sensitive information, maintaining the system's integrity and data privacy. For our third constraint is latency. We track the delays in operation using timing tools. These tools helps us measure how long the system takes to respond to various requests, helping us monitor system responsiveness and user experiences. For our fourth constraint is parameter. Parameter is measured by tracking how often the system performs within its allowed parameters over a defined period. Meaning, this guarantees that the system consistently operates reliably without deviation or errors. For our fifth constraint is time, was calculated by dividing total processing durations by number of order handled. This metric allows us to evaluate how efficiently each transaction or customer interaction is processed. Now, for our sample trade-off analysis, we compare two constraints in this system, which is performance, which measures processing speed, and time, which refers to average handling time. We use the technique Otto-Antonson model to understand how changing one affects the other. Now, looking at this table, we have two scenarios, which are the manual system and the automated system. Both are set on the same scale level, 10. But their performance and handling time differ. In the manual approach, the processing speed is 0.067 orders per second. Then in the automate is 0.20 per second. Then in the time for the manual, it is 15 seconds, while in the automated is 5 seconds. Now, to quantify the trade-off, we first calculated the percent difference for each constraint using the formula. Formula of percent difference is equals to higher value minus lower value divided by higher value times 10, which is our equation 1. For our equation 2 is subordinate rank is equals to governing rank minus percent difference. Now, let's move on in calculating our performance constraint. Firstly is percent difference. 0.20 minus 0.067 divided by 0.20 times 10 is equals to 6.65. And for our subordinate rank is equals to 10 minus the percent difference, which is 6.65, is equals to 3.35. For our next constraint is time. The percent difference is equals to 15 minus 5 divided by 15 times 10 is equals to 6.67. And for the subordinate rank is 10 minus 6.67 is equals to 3.33.
This means that improving one constraint, either increasing processing speed or reducing average handling time, causes the other to decrease by about 67%. In short, both speed and time efficiency cannot be maximized at the same time. The Otto-Antonson model trade-off shows that when one is optimized, the other drops by around 67%, based on the calculated percentage difference of 6.65% for performance and 6.67% for time.